So this is actually kind of a general philosophy question. So if you have some triangle, right? Like, oops. This is the vaguest triangle ever. Okay, so you have some rando triangle, right? And you used law of sines to find this, right? So you said, okay, theta is sine inverse of some garbage that you got from somewhere. How do you know whether you have to consider two angles or not? Well, if you don't know anything else, you probably have to consider two angles. You guys see that? Those angles are going to look like theta, which is the arc sine of whatever stuff you got. And what's the other one? Okay, so theta is some angle here-ish, right? I mean, forget that this angle doesn't look like the one in the picture, really. Where's the other angle that has the same sign? Okay, it's kind of reflected into the second quadrant, right? So that's this angle. What's the actual angle measure on that one? No. That's saying this thing's theta, right? So that's go all the way to
180 minus theta.
Yep, so you have to do pi minus theta or 180 minus theta, right? Depending on
Degrees or angles.
yeah, depending on what your calculator was set to. You guys see that? So one trick you can use is if you know one of the other angles already, sometimes there isn't space for this one.
Okay.
See that? But when they're close to 90, there's usually enough space left. That make sense?
Yes.
So, like, for example, say I knew that angle A was 100 degrees, right? And then angle B is the arc sine of something, right? And out of my calculator, I get that this is 75 degrees. You guys see that? If I take the other angle, right, that'd be 105 degrees. And there isn't space for that because A ate up too much.
Okay, so that's
See that?
okay.
So sometimes you can write it off because the other angle, like maybe you know an angle already and it's taking up more space than this thing needs. But if you know nothing else, you have to consider both of them.
Okay. And so what happens if you use that to find more than one angle on the triangle? You have to consider both of them?
Yeah, you'll have to pop this into two separate triangles and solve everything for both of them.
Okay. So what I was saying is you did that for that angle, so that gives you two triangles. But then you do it for another angle. Oh, you shouldn't have to.
Yeah, you won't have to do it for the other one, right? Because once you've got,
Or what if they only gave you no angles and only sides, and you have to find all of them?
if they give you no angles and only sides, I would use the law of cosines, not the law of sines. You guys see that? Because the law of sines in there is going to have two things that aren't determined. So you're not going to be able to use it anyway. You guys see that?
Unless you get one like value.
Did
You-
law of sine, the law of cosines on one, and then use the law of sines on the rest of them.
Sure, yeah, that'll work. I would, in that case, use law of cosines to find the biggest angle, and then there won't be space for the complements.
Well, I picked which one I thought was the biggest angle, and it turns out it was, so I got lucky.
Yeah, it should be the one opposite the biggest side.
But all of the triangles are not drawn to scale, so.
Yeah, so just find the biggest number,
Okay.
right? Use that as C. Does that thought process make sense?
Yes.
You guys all kind of,
Biggest thing.
I'm sort of randoming this thing, but yeah, if they give you, if you get a triangle like this, right, and you're given 8, 9, and 10, use the law of cosines to find this guy, the guy opposite the longest side, and then there probably won't be space for these complements. The other thing you could do is just use the law of cosines for all of them. You guys see that? or use the law of cosines for this one and then get that one out of,
Just add two angles.
yeah, they have to add to 180. Cool? Is that, try it? Alright, that gets video.